Hey Wheat North, Mr. Igler here. This is going to be just a quick video on Lewis acids and bases. It's another definition. It's a broader definition, but it encompasses all the other ones, so it doesn't contradict anything. It just kind of includes a few examples that the other definitions don't include. So let's just go through them real quick. The Arrhenius acid or base is going to be based on what is produced in solution. So that's usually that's your generic acids that start in H, right? They always start in H because they produce H and the H comes off. Whereas the bases produce an OH. So that's your most common bases: sodium hydroxide, lithium hydroxide, potassium hydroxide, all the hydroxides essentially. Bronsted-Lowry came later and kind of included a few more. NH3 is a good example of a base that is Bronsted-Lowry base, but it's not an Arrhenius base because it doesn't have the OH that it produces, but it kind of indirectly produces one. With Bronsted-Lowry, it's all in what's happening to the H. Is it getting donated? Is it being given off, or is it being accepted? And so water can act as a Bronsted-Lowry base or an acid, depends on what it's with. If it's gaining an H, it's going from H2 to H3, it would be a base, and then the H3O plus would be your conjugate acid. Whereas if it's an acid, if it's giving off the H, it goes to OH minus. So the OH minus becomes the conjugate base. Now with Lewis acids and Lewis bases, we're going to focus on the electrons. And here's an example. The electrons are kind of donated to the Lewis acid here, to the BF3, and notice that actually results in a covalent bond that's formed. That's often the case with Lewis acids and bases. Here's the exact same thing. It's just kind of shown in a table format, but just notice the difference between all these different types of acids and bases. With Lewis, we're focusing on what electron pairs are doing. I like to remember this by remembering that Lewis acids accept electron pairs. So acids accept electron pairs. We're not going to do a ton with Lewis acids, and so it's not vital that you get a lot of practice with this, but you do want to be familiar with it in case you see it here or there. So here's another example. The electron pair is being donated to the A here, so that's the acid. The Lewis acid accepts the electrons, and notice that a bond is formed. Sometimes that's called an adduct. The product from the Lewis acid and the Lewis base getting together is often referred to as an adduct. And that's really all you need to know. I just kind of want you to be familiar with the idea of a Lewis acid or a Lewis base. This is used a lot more in organic chemistry. We won't see it a ton in AP chemistry, but I do want you to be familiar with it. I want you to have seen it before so that if it pops up, it doesn't kind of freak you out. If you have any questions on it, be sure to write those down and we can go over it in class. All right, this is Mr. Igler signing out.